Welcome to another session of the 2020 GovHack Virtual Conference. We are a festival of ideas using open government data to make our communities better places. GovHack is an international competition for people of all abilities who seek to make life better through open data. In 2 weeks' time, on the weekend of 14th to the 16th of August, thousands of people will come together in what has become one of the world's largest open data competitions. We will be offering an interactive experience through YouTube. So, if you are watching live and viewing the embedded video on our hackerspace, click on the YouTube logo to open the video in a new tab and join the conversation. Feel free to ask questions during the session. We will be answering them at the end of the talk. This afternoon, we will hear from Sathish Moorthy, the product lead for the citizen science platform at the Atlas of Living Australia. He'll be talking about exploring biodiversity data. The Atlas of Living Australia is one of CSIRO's national research collections. CSIRO provides web services that enable websites such as the ALA to allow people to explore CSIRO data in a user-friendly way. So I'm going to hand over to Sathish to start his talk. Please enjoy, everyone. Welcome.
Thanks, Katie. Thanks for the introduction. I would like to take this opportunity to thank everyone who involved in the GovHack committee, and a lot of works have gone through in getting this up and running. And thanks to Jason, who's behind the scene, who's streaming the video on YouTube. For the participants, I'm really looking forward to see the new ideas you're going to come up with. I'm really excited to see what innovation you're going to come up with. Let's get started. Today I'll be exploring biodiversity data, and my name is Sathish Moorthy. I'm on the product lead for student science platform. So what we are going to in this session is we are going to give an overview about ALA, and then everyday usage of APIs, and why use an API? Why not have things on in-house rather than using an API from external providers, and how to access ALA biodiversity data. And finally, we're going to have a demo using a Postman REST client. So what we do at ALA, we aggregate Australian biodiversity data from different sources, from universities, museums, government agencies, and even from CSIRO. We collect that information and we make it available for everybody to use. We have an online portal, ala.org.au, which is an open platform. We have currently 89 million records available, occurrence records available for users to download as well as to browse those records from more than 8,000 data sets. As I said before, it's a free online platform. It's a SaaS product, software as a service. It's hosted at Amazon Data Center in Sydney, and also some are hosted in Nectar and also in CSIRO infrastructure. It's a cloud-based platform. What problem we try to solve? We used to have researchers, scientists, and decision makers used to work with the fragmented data set. And we are trying to collect as much as data from everyone and trying to aggregate it and keep it in one umbrella and share it with everyone. How it's going to be useful? It's going to help them to make informed decisions for and also improve the heavy significant gains, and also improves the data management side of it. We are funded by NCRIS facility, National Collaborative Research Infrastructure Strategy, NCRIS, and we are hosted at CSIRO. Before getting into the biodiversity and ALA APIs, so for those who are non-IT technical people, researchers and scientists, I just want to give a bit of analogy about everyday usage of an API. Most of you would have used Siri or Alexa products, Google or Apple products to ask some questions to get some information from Siri or Alexa. What's happening behind the scene? We just ask the question, and then Siri takes the voice and converts that into a text field, and then it passes and goes to different servers. If you're asking about weather, it goes to a weather channel server. If you're asking about stock or finance, it goes to a Yahoo server using an API. It retrieves the information and gives it back to us. And all happens within a fraction of few seconds. There are lots of APIs it interacts with, whether it's a news channel, if it's ABC, channel 10, channel 9, it interacts with those servers to pull the information for us. Why to use an API? Why can't we have things built, every components to be built by the organization? Why should we go to the third-party provider and pull those information? First of all the energy and the time, the valuable time can be directed towards what's important to a business or what's important to the research. You can be focused on that rather than reinventing the wheel for every individual component. Mostly some of those small problems are solved by other providers taking benefit out of that using an API. Naturally, it is going to reduce the in-house cost development because you're not going to do entirely everything. You'll be mainly focusing on core innovation which you're working on. Example, in a Siri case, they're mainly focused on the AI engine converting the voice to a text and understanding those is the main core idea. It's easy to switch providers. If one provider doesn't satisfy all your requirements, you can always switch to another provider and consume their data. Initially, when Apple started, they are interacting with Google Map API service, and later that they moved on to build their own one because it didn't satisfy their need. So that's the bit of overview about why we need API and where we use in everyday's life. Jumping on to the next one, how to access ALA biodiversity data. We have a published API documentation. You can access that from api.ala.org.au, where we support mostly JSON-based data structure. We do support XML, but not all web services are available in XML. JSON is the main thing, and you don't need to register to access the data. It's open source. You can most of the queries are freely available for anybody. Can just go and access those APIs. Okay, how I'm going to structure the rest of the session is rather than just giving a raw data and just showing the API URL. From the client perspective, the left side is going to have a picture which is going to show you how the end user will see the result of the API call. On the top right corner, we'll have a URL which will tell you where to go and put your request in. On the bottom, you'll have the response which you receive from the server. And I'll also jump into the ALA website to show where we have used these APIs. So it'll give you a bit of context rather than just showing a raw JSON response. So the first one is species autocomplete. Those who have been to ALA website, you've seen the homepage itself. There will be a text box where you can search for any species you want. We use an API there to do an autocomplete to start with. So in this case, we are just typing the MACPy, and the system automatically goes to the server, pulls the matching query, and gets you all the species which close to MACPy, MACPy lark, MACPy sweetlips, and other species there. You will be passing the query, and the autocomplete list will give you not just the name, it will also give you the common name, scientific name, and it will also give you the unique identifier GUID. Once you have the GUID, the next step, obviously, you want to know more about the species. So there is a API. You can see species-specific API where you pass this GUID and that will give you all the information about that particular species. Not only it also gives the multimedia information, the images, and the author of that species, and then when it's been published, taxon information, a lot of information can be retrieved using that API. Let me quickly go to the ALA website to show you. Let me search MAC5. You can see as I type, it's going to list all the species here. Let me search for MAC5 large, and you can see the first result. And you want to explore more about the species. This is where you go. And behind the scene, what's happening? This is the web service we are using it, and anybody can use this web service to retrieve the same information. Once you retrieve the information about the species, you want to know where all these species is occurring. So there is an API for that too, and on the top right-hand corner you can see an occurrence API which comes from a BioCollect server. You pass a couple of parameters. The query parameter where you can say what species it is. You can either pass the taxon name or the GUID which you have retrieved from the previous web service call. So once you pass that, it's going to give you detailed information about the occurrence of all about species across Australia. We have found 936,000, more than 936,000 occurrence record for this species. On the right side at the bottom, you can see the total records found. You can see the total records found, and also it gives you all the taxon information, what kingdom, what class, what order, and all details related to those specific query. Moving on, let's before that, maybe I'll just take you to the website, and then if you browse at the bottom of the screen, you can see view records. So if you click on the view records, you can see all the occurrence record for that particular species, and you can also see the images, map related data. Those can be retrieved using the above API which I just outlined. Again, once you have retrieved those information, you want to know specific record. There is an API for that, ws/occurrence, and then you have to pass the UUID of the record. That's going to pull all the information related to the record. The rights, copyright information, who provided that information, what's the latitude and longitude of that record. All this information can be retrieved. If there is images, then we'll also provide image URLs for that record. So let me go into one of the records. There you go. Let's go to one of the records here. You can see the images here, where it's been found, and who provided this information. All the details can be retrieved. Okay. On top of that, if you want to filter the records, you want to see what records only related to this species, plus you want to see only the records which has the images associated to that. There is a query called FQ, or there's a parameter called FQ where you can pass multimedia colon image as the parameter, which is going to retrieve all the records with images. There are more parameters you can pass. I'm just giving you only an example of few, but if you go to our ALA API published documentation, where we can see all the parameters, customizable parameters, which you can use and retrieve the information. In this case, if you want to retrieve records linked to state New South Wales, there's a state facet query parameter which you can use to retrieve those information. Let me go to the ALA website. Let's go to the occurrence record. So here on the left side, you can see there are lots of different facets. So these are the ones you can use. Let me try the images one. So now it's been filtered to show records which has images in it. And you can also use other facets, or you can even customize the facets. You can use the identification, taxon, location, record, assertion, and attributes. All these are supported. Those can be manipulated, or you can pass this query to filter your result sets based upon the facet query. And this is one of the popular queries that can be used for your prototype. What reptiles is around for given coordinates? I want to know reptiles or mammals, or what type of species is around next 5 kilometers or 3 kilometers. The URL, the API for that is an explore ws/explore/group. In the group, you pass whether it's a reptile you're after, it's a mammal you're after, and then you can also pass the latitude and longitude, and then you can pass the radius parameter. In this case, I'm just passing 5 kilometers. That's going to give you detailed information about the species, the common name, what family it is, what kingdom it is in, and detailed information. And after that, you can start exploring more about that group of species. I'll take you to the demo section. So all this information will be shared with you at the end of the slide. We will have published APIs, plus we also have a GovHack information and developer information. All this will be shared with you at the end of the session. And even the client, Postman client, REST API collection will be shared with you. So you can use any of your client you have to pull the data from the different servers. In this example, I'm going to show you Postman. Let's start with the species autocomplete, which I just mentioned. You can see the URLs. Mostly it's all GET request. You're just pulling the information. Okay, I think I haven't changed my screen. Just give me a sec. I'm just trying to share the Postman client. Okay. All right. I hope everyone can see the Postman client. Yep. Okay. The species autocomplete is we can pass a query parameter, MacPy as an example, which I sent. Let me send a request to it. There you go. You got the result back in a JSON format. And you can see the common names, GUID, and all the records details here, what rank it is in. If it has a scientific name, it will also have a scientific name. So now let's move on to the specific profile, species profile. You can see here we are passing the GUID of it, and this API call also supports JSON-P. So you can see that if you provide a callback, it's going to give you, here you go, you could, I'm just increasing the font size so everybody can see a bit more clearly. Hopefully it's a bit better. Okay, so that's the return information to retrieve the species profile data. It will also give you a GUID and taxon information, who published that information, and also the classification. If you want to retrieve the classification, that's also possible. Kingdom details, common names. There are multiple names sometimes for a species that will also can be retrieved using this API. So that's the second one. And the third one, species occurrence. We are here passing the only one query now. We are passing the identifier, GUID identifier. Let's send the request. There you go. So we found 936,000 plus records, total records. And using the page size and the start index, you can manipulate and get the next set of results. In the occurrence record, you can see a lot of different IDs. You can find the UIDs and there are catalog numbers and when that event has occurred. And you can also see the data resources, which group it comes under, animal or a bird group. And you can also find a lot of map locations, lateral longitude of that record. You can be able to browse and you can see all those information here. So that's to get the species occurrences. The fourth one is species occurrence record, where you pass the ID, which you would have got using the previous API call. Let's send a request. Here you go. It also gives you image URLs which can download for that species, and it will also show who recorded that occurrence. And other details like the event date, event time, even attribution. You can see all the details linked to that record. Moving on, let's go to the image filter, which I've explained before. You can, on top of passing a query parameter, you can also pass FQ parameter, where you can say, I want to retrieve all the records which has image in it. So you pass the image. Here you go. So you found 625 records with all the images in it. Where is the image URL? Here you go. You can see all the image URLs. All right, and then more facets, as I showed in the web portal. You can pass more than one facet query. Here I'm passing the year, which is 1970, and also a state param. That's going to narrow down the result a bit more. Actually, there's no data found for that criteria, but that's how you can able to add multiple facet query and retrieve the data for it. Close all tabs. Okay, so we've done until here, and let's go for the reptiles around the 5-kilometer radius. We will be posting this query against the BioCache server, and the parameters will be passing here. The main parameters you need to pass here, some are optional. The main ones are latitude and longitude, and what radius, what kilometers you want to retrieve data for. Okay, let's send this one. Still loading. While that's happening, so same like that. Whatever data it's going to return, it's going to be in a JSON format. Okay, here you go. That's the result set. You can see what's the common name, and also the kingdom and family related information can also be retrieved. Okay, so now you've seen how you can browse for a species, how you can see the detailed information about the species, the occurrence of species around Australia, and you can able to filter it based upon state, based upon the date, and so many facets where you can use it to filter. Now it's moving on to the map. We also support downloading the PNG image. Let's say you want to know all the occurrence for a koala in Victoria, and you want to have that in the image format. There is an API available, BioCache. It's also coming from BioCache server, and you pass all these parameters, what layer you want, base layer, and you can also, you don't have to pass all the queries, you have to mainly pass the species information, the ID. And then the file name. In this case, is koala. If I send it, it's going to be like an ASCII. But if you use this in the browser, you can download the map. Let me show you what I mean. If I so that's an image, PNG image. But if you use your browser to download it, it will download the proper image for you. So that's for downloading an PNG image of a map. Sometimes you don't want to do a live API call. Instead, you want to get the data in a CSV file. Let's say, in this case, we're going to download, we're going to do a request to download the data in a CSV format. This one is all eucalyptus species in New South Wales. So the facet query is stating that we're after New South Wales one and an ID. And then let's send a request. Okay, you send a request. The request has gone to the queue, and then you can you'll respond it back with the URL that you can see the status of your request. If you copy that, go to your browser. If you use a browser and follow up on the status URL, it will give you an URL to download the CSV file. So on that, you can use it for an offline usage, so you don't have to use an API call every time to retrieve the information. All right, and then moving on, we list of spatial layers. We support a lot of spatial layers. Let's do a request for that. That will give you the supported layers. I can't remember exactly how many we support, but we do support lots of layers. So this API will be able to get those information about the supported layers. We also support WKT shape downloads. And there's an API for it, ws/shape/WKT, and then you have to pass which layer, which information you want, the ID of it. So let me pass this one. Here you go. So it gives you the full details, all the coordinates for that request. We also support GeoJSON. If you are after GeoJSON, not the WKT shape, then you can send the same request with a GeoJSON in the URL. There you go. Now the format is in GeoJSON. Okay, sometimes you don't want to get the map tiles, or you don't want to get the GeoJSON or WKT. You want to retrieve the static map. We have an API for that too. It still comes from the BioCache server. You pass the what do you pass? You pass the extents information. Let me show you. It comes in a raw data, but if you're using in a browser, it will help you to download the static image, which you can able to embed on your web app or mobile app. So these are the only handful of those web services I've shown you today. If you go to the api.ala, as I said, there are lots and lots of APIs available, which I will take you there now. Okay, share. Just share my. Okay. Okay. You can use. Let me go directly there. You can see all the APIs listed under one umbrella. That's api.ala.au. We'll show you what we support: JSON-P, JSON-P, or JSON formats. If you click on the API, it will give you detailed information about, with an example of how to retrieve the data. And we also have another platform called BioCollect. What BioCollect does is it's a citizen science platform. Let me take you there. BioCollect is a citizen science platform, and this is specifically set up for a bushfire recovery hub, projects related to bushfire recovery. If you're doing any prototypes related to bushfire recovery, this might help. You can browse all the projects. Currently, we have 27 projects related to bushfire recovery. And one of the example project is in the CSI. Open that. So you can see it's been tagged as the bushfire recovery work project. And it will have a lot of surveys and associated data with it. If you want to retrieve those information, we have an API for that too, which I will show you at the end of showing this UI. Here, the same thing. You can retrieve all the species images. You can see where the record's been found. Within that image, all the information can be retrieved using the API. Let me go back to the API. All right. So the last last three API calls which I'm going to show today is mostly related to bushfire related projects. So if I click on that, this comes from a different server called the BioCollect server, not the BioCage server, where you pass most of the things are optional here. The main thing is if you're after a bushfire recovery project, you have to pass a parameter called hub as a bushfire recovery. I'm going to send this one. Okay, so it's returned with all the projects associated with bushfire, some detailed information with it. We'll also show you some additional metadata associated with the project. You can able to retrieve all those information using the call. All these web services I was showing you today, you don't have to register with the ALA. You can able to put the request without creating any APIs for API key for it. Okay, let's go to the next one. So now we know all the projects related to the bushfire. Now we want to see what are the activities, what are the records that's tagged to the to those projects. So you just pass. You pass the hub attribute, which is a bushfire, and then additional parameters. Some are optional. Maximum data you want to retrieve, what type of sort you want to do, a last updated field in this case. Let's try this. So that's going to give you all the records associated to those project activities. And it will also give you the images, if there is any images associated to that project. And will also give you whether if the data is embargoed or not. In this case, it's not embargoed, so you can use this data for your prototyping for your project. Okay, let's go to the last API. Now we have seen, okay, this is also another API to retrieve your data, where you can also pass the search parameters. If you're after something specific in that project, not all records, you can pass this search query. That will retrieve you all the records. This is just an overview of what we have, and I will try to share. I'll try to share this in the GovHack information, so you should be able to download all these APIs and try yourself. Going back to the main screen. Just switching the screen now. Okay, all right, so I'm back filling in. I'll try to show you all the information you might need. ALA for developers. So if you go to ala.org.au, At the bottom of the screen, you can see a developer tools and documentation page, which will be a starting point for you. It will give you all the information about how to access the web services. And even if you want to look at some of our source code examples, you can see that information. Yeah, we host all the source code at a GitHub repository. So you can see that. And there is an ALA GovHack page. GovHack page, which gives you a bit more brief introduction about where you can get all this information. You also have a Postman link, which you can use it to download the data. And some examples here too. That's pretty much I want to cover today. I'm happy to answer any questions. Okay, I can see a few questions out here. What kind of rate limits does the API have? That's a good question. I don't have the right number of, I don't have the details about that, but we are pretty good. We are pretty good in handling a large request, but I can get back to you on that information. I don't have that with me. Back to you, Katie.
Okay, thank you. We've got a number of questions that have come in through the chat.
I'm just looking through some of them. There's a
So,
news.
Yeah, so one of these is from Brett. Thanks, Brett. About, does New Zealand have an equivalent resource?
I don't think we have a New Zealand information at the moment, but I can check that for you and I can get back to you. Thanks for your question, Brett.
Okay, and we have another one from Jeff and a comment as well. So the comment is, this is pretty amazing. From a temporal perspective, how often would an occurrence record change? For example, could we monitor the koala population in southwest Sydney over time with this service?
Yes, so you can monitor the information using the portal or using the API. You can be able to download and get those information. We used to, I think I can be able to show you that one too. If you go to the main ALA page, you're looking for koala. Search for the koala. Let's put this one. And you can see all the occurrence record using the view records link. Here there is a place where you can able to see by decade. You can filter the records here, so you can even go front or back, and you can filter the records, occurrence records. Let's say you want to know all the records from 1950. There we go. There is no images, but you'll have all the occurrence record details enabled for free. So yes, you can get those details. Hope this helps.
All right. Are you able to make this just a little bit bigger so that
people can see? Yep, sure. Is it better?
Excellent. Thank you. Thanks.
Yeah. So you can.
Okay. So just as a hypothetical, all right. So the data in the Atlas of Living Australia, that displays. Does that display data that is collected by people, like if they're out and about and they are taking a photograph of a koala and they're using iNaturalist app to collect that data, and that goes into the ALA? That's correct, isn't it?
That's right.
So you could potentially, yeah, okay, you could potentially repurpose data that you've collected around a specific species into another app, or mash that up with other data using these web services. That's great.
That's right. Yeah.
Great.
Okay. On top of getting it from different sources, we also individual user can go and upload the sightings of a species into ALA. So even that's available.
Yeah, excellent. No, I've got to say, from a personal perspective, I've used the frog collecting one to record frog sounds to add them into. So excellent. Now we've got one other question here. What kind of rate limits does the API have?
I don't have that information with me, but we are reasonably scalable platform, and our infrastructure is running on Amazon server, as I said before. So it is pretty good, but I don't have the number right now.
Okay. All right. So I've got a comment here saying I'm involved in a rewilding project near Deniliquin in New South Wales. This would give us an idea of species observed on the property since the inception of records. Oh, okay, so in the area. So
Yes, that's
yeah,
right.
okay.
If you go to the ALA's main page and then explore your area, that's a good tool to try, and then you should be able to find all the species around that area too, if you want to.
Okay. So using the API, you
Yes,
could then use some geographical coordinates to send to the API using like a get command to pull that data out
that's right.
into JSON. Yeah. Okay.
That's right. Yeah. The one example which I showed you before is so specific to the passing a latitude and longitude along how many kilometers radius you want to see the species information. Yes, it's possible.
Yeah.
In the documentation, I try to add specific notes to it, so you should be able to download the API reference.
Yeah. Okay. So in terms of citizen science collected data, are there particular apps that you suggest people use if they want to contribute to? Okay, so project finder. So it really depends on the type of data you're capturing as well, and particular projects.
Yeah, even if you want to have your own project running, this is a good platform. BioCollect Citizen Science is a good platform where you can create your own project, you can collect data in it, and there's an open API for you to pull those information to your app if you want to.
Yeah, yeah. Fantastic. I wonder if all right, so here's another question. Okay, so just as an example, so a collection that was, say, might be submitted from another data provider, let's say the Data Access Portal, which is a CSIRO system. So that data is submitted and also filters through to the Atlas of Living Australia. So there are other scientists contributing through various other platforms. So do you know what other platforms ALA picks up data from?
We get it from iNaturalist and museums,
Yep.
from different museums,
Yep.
from government department. CSIRO is definitely one.
Yep.
Different institutions too, but museums are the main data contributor to it. But you can able to see those things from the data set itself. If you are specifically looking for a koala or Mac, let's go for MacPie.
G. Magpie.
Here we go.
Yep.
If you look for the MacPie, there is well, it's loading. It usually tells you where the resource comes from, which data source it is. If you look for the data source attribute, metadata, you can find out where it's coming from. So yes.
Yeah, fantastic.
Okay. And then if you look at all the occurrence record here.
Yeah, they're pretty common, hey?
That's right here. But this, because this one is common, you can see the data is actually coming from iNaturalist Australia.
Oh, bowerbird.
This one's, and you can also see the bowerbird one.
Yeah.
Let's go back.
Yeah, okay.
So you can filter it, you can see where the data is actually coming from.
Yeah, that's really interesting.
I think there's also a customized field. Yeah.
All right, so now's the time to get in any last minute questions. don't want to let me monopolize it. Now, there will be other ways that members of the public can get involved with the ALA as well. I remember in the past reading something about transcriptions of labels. Is that still something that people can get involved in?
That's correct. Yeah, if you go to the bottom of the ALA page where you can see a lot of other
There it
tools
is.
we support.
Is that Digivolve? Is that the one?
Again,
Transcribe and digitize?
there you go. Here, still loading there. Yeah, people can be able to get an account with an ALA, and then they can be able to get involved in transcribing things. There are lots of volunteers already being involved in it. You can see a lot of expeditions here.
Fantastic.
You can see there are 7,410 volunteers involved in transcribing things using a visual platform.
Yeah, that's great. Oh, to be retired. I wish I would do more things like that. And we've just got 2 more questions. So thanks, Jeff, for that. So one of them, his questions is around update cadence.
Not sure what that means. Will you be able to elaborate that?
Okay. And so in terms of yearly records or weekly records.
Okay, yeah. Would you be able to update the yearly record? Yes, we can. If you can, we can able to update the records. If you contact our data management team, they will be able to help you and provide you all the details on how to upload the data and how to maintain the data. That should be okay.
And would occurrence records get updated frequently?
Yes, we do get update requests, and we do have a dedicated team looking after to update records. Yes.
Fantastic, thank you. Thanks for those great questions, Jeff. All right, well, we might thank Sathish for the wonderful informational session that he's provided. I really appreciate that, and our users do too. So this is the last in our series of conference events. You can watch any of the sessions that you might have missed on our YouTube channel. Now, we do have other events happening though. So this evening, we have our first Connections event, which is the New South Wales event. And if you want to find out more information about our other Connections events, please have a look at the GovHack hackerspace. And I will say thanks again to CSIRO, to NCRIS for research infrastructure in Australia, to Sathish and the Atlas of Living Australia. And I really do encourage you all to have a look at these additional websites and get involved with helping to record Australia's biodiversity information. Thank you very much, everybody.
Thanks, everyone. Thanks, Betty.